Good morning. Today we're starting a new unit. Unit 10 focuses on inequalities. We'll be graphing inequalities with one variable at the beginning of this unit, and then the second half will be graphing linear inequalities and systems of inequalities. So today I think you'll find this to be somewhat of a review because you'll be solving these inequalities just like you'll solve an equation, and then you'll be graphing them on a number line. So let's get started. Our objective is to solve and graph inequalities with one variable using all four operations. Remember, the solution to an inequality is any value or values of a variable that makes the inequality true. For example, x is greater than 10. The solution is all numbers that are bigger than 10. So the rest of this first page is the property of inequalities, and it mimics the properties of equalities, which we've gone over way back in the first semester when we started solving equations that were one step. Remember that the addition property means that if you add something to one side, you have to do it to the other. You have to do that with an inequality also. Subtraction property said if you're going to subtract something from one side, you have to do it to the other side. Same with multiplication. If you're multiplying on one side, you must do it to the other. And finally, with the division property of inequality, it's the same as well. You must divide both sides. All right, so let's start with the second page, and it says to solve an inequality, you'll follow the same process used to solve equalities. When adding and subtracting, the process works exactly the same as solving an equality. For example, x plus 7 equals 6 is an equation. If I subtract 7 from both sides, I get x equals -1. In set notation, it says x such that x equals -1. So now I have the inequality, x plus 7 is less than 6. I'm still going to subtract 7 from both sides, and I get x is less than -1. In set notation, that is x such that x is less than -1. The difference about multiplying and dividing a inequality is that you must remember, by a negative, you must remember to reverse the direction of the inequality symbol. If you're multiplying or dividing by a positive number, you don't do this. It's only when you're multiplying and dividing by a negative. So, for example, if I have 5 is less than 8, that is true. However, if I went and multiplied both sides of that inequality by -2, I get -10. And then it is not less than -16, it becomes greater. So I have to change that inequality symbol by reversing it to greater. So that's what that means. Likewise, if I have 1 is greater than -4, if I went and divided both sides by -2, I would get -1/2, and that is not greater than +2. So I have to switch the inequality and make it -1/2 is less than 2. And they did a final example there by showing you -7x is less than 42, but when they divided by -7 to get x by itself, it became greater than -6. All right, let's look at a little terminology and just remember, just make sure you remember the symbols, and then we'll talk about what it looks like when we graph it on a number line. The first inequality symbol is the less than symbol, that is in blue. The graphing symbol is an open circle. Open circle on your number line, and you will graph everything to the left that is smaller. The greater than symbol is pink. It is also an open circle, and you will graph everything to the right. The less than or equal to symbol is in yellow. Notice that it has a line under the less than. This is now a solid circle. And you will graph everything to the left. The purple is a greater than or equal to symbol. It is also a solid circle. And you will graph everything to the right because it is bigger. Okay. Let's do some of these practice. It says solve and graph each inequality. Write your solution in set notation. Remember to reverse the sign of the inequality if you multiply or divide by a negative. So some of my problems didn't come through because it was an outdated math editor that the equations were originally put in. So I'm going to go ahead and do some of these so you don't have those funky symbols there and no inequality. So the first one we're going to do is g minus 4 is greater than negative 4. To get g by itself, I'll add 4, and I get g is greater than 0. In set notation, this just means g such that g is greater than 0. You can start wherever you want. I'm going to go by 2s. You could go by 1s. You could go by 5s. Open circle on 0, and because it's less than, and I'm shading everything to the right. I'm also going to do number 3. That inequality was 4q is greater than 48. I'm going to divide by 4, and I do not need to switch my inequality because I am not dividing by a negative. In set notation, this is q such that q is greater than 12. Let's see. For this one, I'll go by, let's go by 6s for something different. It's an open circle on 12, and it's also greater, so I'm shading to the right. Number 5 did not fill in with an inequality either, so I'm going to go ahead and do this one for you. And this one is x divided by negative 3 is greater than 12. I need to multiply both sides by negative 3 to undo the division. When I multiply by a negative, I switch the inequality. I'm going to make a little note, switch inequality. Multiplied by a negative. Okay, so negative 36 in this case, and I had to switch the inequality, which I didn't do, so let's go back and do that. So that's negative 34, negative 36, negative 38, negative 40, negative 42. Open circle, and I'm shading everything smaller than that. Okay, let's fix that arrow. Oh, took it all away. All right, let's see. We have a couple more here. I'm going to do number, let's switch it up. I'll do number 8 and number 10 with you, and then I'm going to have y'all practice the ones we didn't do. 3x plus 4 times the difference of 6 and x is less than 2. I'm going to distribute, and I get 3x plus 24 minus 4x is less than 2. Okay, so now I'm going to combine my like terms. I'm going to get a negative 1x plus 24 is less than 2. You're going to subtract 24. You're going to get negative 1. X is less than negative 22. Divide by a negative 1. So x, I got to switch that inequality. I'm going to put switch inequality is greater than 22. In set notation, that's x such that x is greater than 22. Okay, you can just start right here. You don't have to start at 0 if you want to label. Because remember, this is just part of a number line. We haven't had any solid circles yet for the ones I've done. It must all be the ones I didn't do. Okay, let's look at number 10. 8w minus 5 is greater than 2 times the difference of 4w and 3. I'm going to share that too, so I get 8w minus 5 is greater than 8w minus 6. Well, what's going to happen? These are going to cancel out, and I'm going to get negative 5 is greater than negative 6. That is not true. Let's see, wait, what do I have here? Negative 6. 8w, my 8w negative 5 is greater than negative 6. And now I need to get, let's move this to this side. So we have 0 is greater than negative 1. 0 is greater than negative 1. But we don't have anything So let's go back and start 10 over because I want to actually show you what it's doing. So 2 times 4w is 8w, and 2 times -3 is -6. 8w does go away, and originally I said that is not true, that -5 is greater than -6, but it is true. So this is going to be all real numbers, our solutions. How does that look like on a graph? Well, that looks like you are taking your whole number line and shading it. And you are putting arrows at both ends because anything you put in there is going to make that true. And it's not even really necessary to number the number line because it just means it's all real solutions. Okay, let's stop here. But before I do, let me put the answers that you should get for the ones that you're going to try on your own. Number 1, you should have R such that R is less than 16, and then when you graph you'll have an open circle to the left. Number 4, you should have P such that P is less than -3. Watch if you're dividing or multiplying by a negative. That's also an open circle on -3 going to the left. And number 6, you should have M such that M is greater than 7, and that's going to be a open circle on 7 shading to the right. We didn't do 7 either. Okay, number 7, A such that A is greater than equal to 7/4. This is going to be the first one where it's a solid circle on 7/4, and you'll be shading everything to the right. Number 9, K such that K is less than or equal to 4. That's also a solid circle on 4. And it'll shade everything to the left. Okay, I'm going to stop the video here for part 1 so that you can try some of those. And then we will pick up in a few moments on part 2.